So often in a textbook type problem, we assume the sample we are working with came from a normally distributed population. In practice, however, when given an actual set of data to analyze, we need to check to see if it is reasonable to use a normal model. So in subsequent lessons, you will definitely need to make the case that the sample could have come from a normally distributed population in order to run certain statistical tests. And this can be especially tricky with small samples. So in this first example, let's look at 4 data sets. We have L1, L2, L3, L4. So which one of these is not like the other? So 3 of these were sampled from a normal population and 1 was not. This is not too easy looking at the data sets themselves, is it? So obviously, I need to make some visual displays. So I'm going to start with histograms for all 4 lists. It appears that from the histograms that L1 and L2 likely came from a population that was normally distributed, right? So L3 and L4 are a little suspect. Let's create another display. Let's create a dot plot for these. And a dot plot reveals a similar pattern. Let's look at the corresponding box plots. So we see that L3 looks a bit skewed, but not too bad to raise any alarms, right? The rest seem to be relatively symmetric and free of outliers. Let's compare the length of the box plot, which is the IQR, right, to the total width, the range. So the box should be less than or equal to about half the width of the complete plot. And what raises a slight alarm for me is L4. So its box is considerably wider than half of the range. So if I look at the width of L4's box, that width of that box is certainly more than half of the entire width of the box. The other ones don't seem to have that occur, right? I mean, if we look at L2, for instance, the width of the box is not more than half of the total width. So the final display we're going to look at is something called the normal probability plot. These plots are usually not created by hand. They can be a little tricky, so it's more important that you can just interpret one, or that you can at least create it on the TI-8384. It compares the actual value with expected normal quanti value. So samples from a roughly normal population will display a relatively straight line pattern along a diagonal. So in this first one here, I'll do my best job to draw a straight diagonal right through there. That should be straight. So looking at ours, L1 and L2 look pretty straight. L3 has a couple of departures from this, right? We have a value over here. We got a little something wonky going on there. Not a big alarm though. And L4 does have a little bit of curvature to it. We see that it often takes several different displays to check for normality. So which one here really was not sampled from a normal distribution? It was L4. Now I knew that because I went ahead and simulated this data using StatCrunch, and I picked a sample from 3 normal populations and one of them that was actually uniform. So even though L3, for instance, looks like it's skewed, it was actually sampled from a normal population. So how to assess normality? We summarize this. Here are the ways. We can look at the histogram. Is it bell and mound shaped? We can look at dot plots as well, box plots. This will help us determine any symmetry, and also if the width of the box itself is more than half of the entire width, it again raises an alarm with me that it may have departures from normality. We can create the normal probability plot on the TI. It should be a relatively straight diagonal line. Or if using StatCrunch, it's called a QQ plot. It does roughly the same thing. There are slight different computations for these, but again, we're looking for straight diagonal line.